Are you a developer who's been scared of manual memory management like me? I'm the average web dev. I talked about it in the last episode. If you haven't seen it, go back and watch it. I'm the average web dev. I've never been concerned about resource allocation, never been concerned about, you know, how fast my program is outside of it running, 10, 20 seconds, stuff like that. And I'm on a path to try to become a better developer, both so I can build things that I want at home and then also extend that into my actual web development work. So recently, I've been going down a path of learning a language called Odin, which is a low level language with manual memory management. Kind of my whole time as an engineer, and I think a lot of other people fall into this category. Uh, I was kind of scared of manual memory management. You hear the term and you think kind of you have to manage the memory of the whole language. If you haven't really dug deeply or you've only looked at C, and not like fully understood what was happening, you might be in the same boat. So, you know, with learning this language, obviously that was a topic that I had to cover. And it actually ended up being a lot more simple than, I had drawn in my head. And that's not to say I'm a master by any means, take everything I say with a grain of salt and kind of do your own research. I'm still building and we'll run into these issues that will make it a little bit painful. Um, but at least for now, and in terms of the base concepts, it has felt, much more easy than I initially thought. And so, when you initially hear manual memory management, when you're coming from a language like JavaScript or Python, it's easy to think that you have to manage the memory for every single variable, right? So, if I have, a value that is an int, and say it's just 8, I have to come in and say, that's going to be an int 8, it's going to be an int 16, it's going to be an int 64, which, understanding these concepts is true, but, I thought that, I had to do something to say, I want to assign, 8 bits, and then later down the line, I would have to manually free that, right? Free the value. And so, I think a lot of people kind of run into this like kind of similar idea of like hearing manual memory management and thinking you have to manage every single piece. Um, but that's not the case, right? And you could do it, but like it would just end up being, it would double, triple, quadruple the size of your code base. It's something that would become very tedious and something, it's easy to want to stay away from. Um, so the first concept that I kind of ran into is where memory is allocated. Apologies, I'm trying out a new app for taking notes. They just put mine behind a paywall, so I'll be working through it a little bit. But in being an engineer for multiple years, you always hear the term of kind of stack. Maybe you've heard of heap allocation, stuff like that. Um, but the concept, you never really dug deep. You never really deeply understood the concept. So it actually very much helps, I think, kind of show what's going on when you do, at some very base level, understand the concept. Um, so, kind of, how does the stack and the heap work? So, most, at least that I've seen all, but I'll say most, languages kind of follow this model where you have an initial box of memory. This is like kind of your main memory block, right? This is where the program starts. This is why this is at least a piece of tying into a lot of languages start with like a kind of generally agreed upon file name or method, procedure, function name, depending on the language, whatever it is, that goes along with main. Um, and so this is kind of your general like starting point for the memory block the program is using. Um, and then where the term stack comes from is every time you call a function or a procedure or, a lot of you will be coming from JavaScript, so I'll just, use the term function. They are, technically different, but in terms of the idea at the very highest level, very similar. So, I have function A and function B, and we'll say, somewhere in A, we're going to call B, right? So let me move this out of the way of my camera. But um, we'll have these two functions. One calls the other, and we'll say main, and then main calls function A, right? And so typical things that'll pass it, procedures or whatever. So how this works is when main calls A, it actually gets applied. It's not always on top. I think sometimes it can be below, kind of depending on optimization. But it takes a memory block for function A and kind of, in essence, adds it on top of main, right? And then on top of that, A is going to go ahead and call B, as we talked about. So maybe it assigns some variables and pass them through or whatever. And so you have the same thing where function B gets a block of memory that sits on top of A. And so for any variable you describe, any data you get that gets stored in the stack, and we'll talk about what doesn't get stored in the stack in a second, but these end up kind of stacking on top of each other, right? Now let's say we get to the end of function B, right? So it returns some value to A. Well, what happens is you will actually, pop effectively this function B memory off the top of the stack. And when that happens, it's instantly deallocated. Well, not instantly, there's some cleanup and stuff, but it gets deallocated off of this stack. And so a lot of this memory, any memory that does live in the stack, which ends up being, kind of the majority in terms of simple data types, primitives, stuff like that, they automatically get deallocated. You don't have to worry about deallocating them. You don't have to worry about any of that. Even how much memory they take up, like you do in some extreme cases, and you'll run into those. But in terms of the base concepts, right, it will get deallocated when the function returns and nothing lives anymore. And then so same thing, once A returns, your computer will go through, will deallocate function A. Anything that lives there will be deallocated. You don't have to worry about it. And so that takes care of like a lot of the cases. You could even say the vast majority when you talk about when you're talking about the number of variables or you set or any memory you use. But that by far does not mean you don't run into, heap allocated memory very frequently, right? I'm just talking about in the fact of a program, you might set, 100 or 1,000 variables and only 10 become heap allocated, 15. So that's something that, becomes a vast majority. But it's definitely something you need to worry about because you will run into it with every program. So what is, heap allocated? What becomes heap allocated? So this differs, very slightly per language. From what I've seen, kind of the general idea is anything of dynamic size. I apologize. Got distracted by my Slack. But so anything of dynamic size goes to heap, right? And so this depends, how your language stores data and stuff, but kind of that's the general idea. So in using JavaScript again as an example, an array is a dynamic size, right? So you can always append to it. You can pop off of it, stuff like that. So the size is constantly changing. So this becomes heap allocated. There's also strings are heap allocated. I believe because you can concatenate with them. I'm still working on that one a little bit. I know from C, strings are kind of like a array of characters, and so that would be similarly dynamic. But anything that can grow and shrink in size, as well as anything that you tell to assign to the heap, right? So you'll run into this kind of a lot when you make things, right? So if you use Go, if you use Odin in this case, if you use the make function, this pre-allocates memory, kind of. It at least pre-assigns it, and so this goes to the heap. And so how is this represented within the stack, right? So again, this depends a lot on the data type, but kind of in general, it seems like there will the stack variable you have, or whatever variable you have this assigned to, is going to live in the stack, and this will be, the idea of pointers. You might have heard about that a lot. You might understand them, but kind of the idea is, if you have this variable, let's say, for easy sake, right, we have an array. In Odin, this would be, a dynamic size, right, of like integers, right? So this array value in the function becomes what is a pointer. So in Odin, this is portrayed as a little caret above pointers. How you reference them and dereference them varies a lot per language, right? But so what this is actually the memory address in the heap, right? And so this says, when you're in the stack, when you're running through the function, if you want to access anything, you will go to this memory address and grab whatever value off of it, or whatever you're grabbing off of it, depending on the data type. So these are the so this is where you need to worry about manual memory management, right? So I'll just triple in that, right? Because this is not living in the stack of the program. So you need to tell the program when it's done, right? When to get rid of it. And so this is something, that's simple as long as you understand these rules. If you can understand when things are heap allocated, right, then you'll know. In Odin, there's two ways to do it. Again, depends on your language, but there is free, which just frees the memory, and then there's delete. So in this case, we would use delete on the array, right? And so learning your language and reading about it, you'll understand, how you deallocate memory, how you allocate memory as well, to kind of make it more obvious when you need to deallocate it. But something that makes it, a lot easier, that I wanted to show you a demonstration of before, you can kind of dig into it, get your hands dirty, is if we go back to the console. So you'll see this is a short little Odin program I wrote. There's nothing you need to fully understand Odin about this specifically, other than all this code. So this code sets up a specific type of memory allocator, heap allocator, that will track when things are allocated in the heap, and then it will remove the things from the allocator's list of things that are allocated once you free it, right? And so this just keeps track of what has been allocated and not been freed. And then there's just a little procedure here to print this out at the end. It's a very simple program to kind of demonstrate the idea. So here we are allocating things in two different ways. So like I mentioned, if using that make procedure in this case, so this is allocating a slice. You can think of a slice, if you haven't used Go or anything, as a dynamic array that sits on top of a static sized array, so it can resize by creating a new array underneath. And then here we do that dynamic int that I talked about. So this is our dynamic array of integers. So this is similar to an array in JavaScript, that it can just change size as you append to it, right? And so you'll see that I have these deletes assigned, but I have them commented out because I wanted to show the actual version of this memory tracker allocation you use. So it only runs for me when I'm in debug mode. So I'll put the debug flag on it, and you'll see it'll run, and it'll let me know, these lines leaked however many bytes they leaked. So these aren't considered, technically a memory leak, because it's just assigned once and gone. Memory leak is more like the program the memory in the program is growing as it's running. So this is like assigning things or allocating things in a for loop and never deallocating them and stuff. But in essence, these are allocated and never deallocated. So it's a similar enough idea to demonstrate the point. So what I'll do is I'll uncomment these. These are very simple statements. Like I said, we're just using delete on what we have allocated. We have a defer keyword in front of it. All that means in this instance is it's going to wait until this procedure exits to run these lines. So once the procedure finishes, it will go ahead and free this slice and this array. So again, we'll make sure that's written, and we'll go back and we will run the same thing again. And now you'll see there are no leaks captured because we have freed everything that we have allocated. So hopefully you see some of these tools, you kind of get some ideas in how you can continue to learn this process. I just wanted to show you, it's not really as scary as it may seem from the outside. I know I might have gotten some things wrong, and I probably did. Like I said, I'm just a beginner as well as you guys. I'm hoping we can kind of use each other to grow and learn together. So let me know if I did get anything wrong, if there's anything that's kind of easy to figure out, or any resources that you guys have found that help you learn kind of some of these topics down in the comments below. Make sure to hit that subscribe button as well if you want to continue down this path with me.